Hello and welcome everyone. My name is Dane Menke. I am the Digital Marketing Manager here at REGENESIS and Land Science. Before we get started with the webinar today, I have just a couple of administrative items to cover. Since we're trying to limit our time to an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we do not address your question, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's webinar will focus on a case study for a petroleum hydrocarbon impacted site where a sequence of in situ remediation technologies from REGENESIS was applied to address residual, sorbed, and dissolved phase constituents. With that, I'd like to introduce our presenter for today. We are pleased to have with us Mr. Jack Sheldon, Senior Remediation Specialist at Antea Group. Mr. Sheldon is a remediation expert with over 34 years of industry experience. He has specialized in the field application of various types of bioremediation and chemical oxidation and reduction systems, with personal involvement in 22 first-type remediation projects in their respective states. He has completed remediation projects in all 50 states and several locations abroad. All right, that concludes our introduction, so now I will hand things over to Jack Sheldon to get us started.
Well, thank you, Dane, for that kind introduction, and thank you to REGENESIS for hosting this kickoff webinar for January 2017. And thank you to all of you who are joining today from around the country, and we're glad that you can attend. My hope is here today to have a succinct presentation so that we have a generous amount of time at the end to answer questions. And I look forward to the Q&A, as that often is as good as the content, just hearing what others are thinking and responding to those questions as they come along. So with that, I'll kick it off. A tale of two ISCO chemistries, ISCO being in situ chemical oxidation, for those of you who are not acquainted with that term, for enhancing free product recovery and shrinking a dissolved phase plume. Now the webinar today is divided up into multiple sections. These are crisp hitter little sections. One is called Setting the Stage, which talks a little bit about the site that I'm going to speak about today, as well as the history and just some of the foundational things related to the project. The second segment of the webinar is called Planning. This is intended to be more about the thought, the thinking that went into the actual development of the remedy. The third segment is Implementation, where we actually look at what was done in the field and some of the issues that were faced along the way, because everyone knows that every project goes off perfectly. But in this case, we'll talk about some things that maybe didn't go perfectly and how we rectified those things. Then we'll get into performance to the extent that I can go through the reams of data that we have, at least to make some points on performance and, again, maybe provoke some questions there. And then lastly, we'll finish up with some lessons learned, and again, as I said, there'll be a generous amount of time for question and answer at the end. So setting the stage, our very first segment of the webinar. Our story takes place in Cedar Rapids, Iowa. So why on earth did I pick a site from Cedar Rapids, Iowa? Well, think about any webinar that you've attended this year, last year, the year before. How many times is a site from Iowa the star of the show? I happen to live in Iowa. I've lived in Iowa for 24 years, and I decided, you know what, it's about time Iowa got a little plug here. So we're picking a site in Cedar Rapids, Iowa. Cedar Rapids is a lovely river community with some of the largest agricultural facilities in the country. In fact, the Quaker Oats plant there is a massive facility with tremendous amount of output, just an amazing place to be at. So Cedar Rapids is a large industrial city. And this is our site in the corner of Edgewood and Johnson. It's just a simple former corner gas station site. Nothing out of the ordinary. Everybody thinks corner gas stations are simple. I could beg to differ that a corner gas station with the complexity that it has with mass and with infrastructure and with a variety of different issues can be as challenging as any large project anywhere in the world. And this is our treatment area today. You can see my mouse, my cursor on the screen. The golden sector here is the area that we're talking about. This is the area of action on the site. This is a site building that exists. All the gas station infrastructure is out of the ground now. And you can see this site has all sorts of complexities. It has a right-of-way with utilities. It has other utilities running through the site. It has infrastructure from prior remediation. It has traffic. It has pedestrians that come through. It has an alleyway adjacent to it. And it has just everything you could ever want to be challenged by on any given site. And you can see from the various dots that are signified, the yellows, the blues, the blacks, the reds, these are all former soil borings, injection points, extraction wells. There's quite a bit of infrastructure that exists on the site. Looking at it a little more closely, this again is our treatment area, which is outlined here. It's got some of the injection points located on it. I've noted that our groundwater flow direction is sort of southeasterly on that site, and it's been pretty consistent from the start. The wells that are circled in red are the main drivers for the site. There are multiple impacted wells here. We monitor 11 of them on a regular basis, but the ones in red, MW15 to the top of your screen right here, EFR1R, EFR2R, and EFR3R are the really bad actors that keep this site from being closed. The other wells are impacted, but not to the extent that these wells are. And we have an occupant, former gas station, so the building's been converted over to a 1-800-Flowers, Flowerama, and I'll make a note about them later, but sometimes you get an occupant on a site that's antagonistic, that's difficult to work with. In this case, we have an occupant that is an absolute dream. They've been cooperative and actually go out of their way to make sure that every time we're on site, they provide us various amenities and work with our field crew to get things done. So that, in and of itself, is a pure luxury. So just remember the flower shop for the very end of the presentation, and I'll get onto that in a moment. This also happens to be what's called an environmental liability transfer site, or an ELT, which means that we have secured the liability, the environmental liability, from the owner. And this is a very interesting scenario. Requires a lot of evaluation and thinking up front. It has a very tight budget associated with it. It also has a designated time frame. Typically, these liability transfer sites will have something on the order of a 10-year time frame in order to take the site to closure or no further action. We, as a buyer, indemnify and hold harmless the property owner, and in many scenarios, there's insurance coverage that goes along with the actual remediation component. So these are not simple by any stretch of the imagination, because they require that a good amount of information be evaluated up front, and that drives the project throughout. So I guess an important point to be made here, there is absolutely no reason on this site in Cedar Rapids, Iowa, for us to dilly-dally and not make progress. An ELT site requires good adherence to cost, and also speedy remediation. It also requires that you're cognizant of the site conceptual model and constantly updating that model as new information comes about. This is a classic wheel, so to speak, that's used in many presentations around the country. Everything from understanding the contaminant background, perhaps understanding the microbial characteristics of a site, for sure understanding who the receptors are, what's the fate and transport of the contaminant plume, the hydrogeology / geology at a given site, and then all the things that are associated with the water, the geochemistry, just the overall field parameters and what that tells us. So the conceptual site model is dynamic and an important part to ultimately understanding the problem and providing the solution at the site. Now, typical service station scenarios, most of the time your impacts come from leaking underground storage tanks or gasoline dispensers. There's always lots of groundwater impact, significant amount of sorbed mass on soil. Very, very rare to find a gas station that doesn't have absolutely dripping wet soils with petroleum product. And there is always LNAPL. It may be there pooled up, and it may find its way into a monitoring well, but many times it's there, it's present as fine ganglia or strands within the subsurface. And these plumes tend to migrate. They go from the very small confines of the service station site, and they move off-site, potentially impacting other receptors. And we typically see BTEX and MTBE, TBA, total petroleum is gasoline, total petroleum is diesel. You know, these are the various constituents of the plumes that one sees on a gas station site. So the history of our site, part one. Again, this is a former gas station, so the infrastructure has been removed, but the problem here manifested itself from a leaking gasoline UST, and it happened way back in 1987. At the time, it was recorded that some of the wells on site showed up to 5 feet of free product measured in individual wells. Granted, most of the wells didn't have anywhere near that, but there were some locations where the product had pooled and there was significant amount of mass that was present. This is also, the site here is, sits upon what's infamous in Iowa are glacial till deposits. And these are largely clays. They have very low permeability. There are silts, and there can even be sand stringers within them. And understanding these glacial tills is critically important, because without an understanding of them, it's very difficult, in fact, to get any kind of quality injection of a remediation chemical. And this site is regulated by the Iowa Department of Natural Resources, the IDNR. The history, part two. So once some basic information was developed by others on this site, the first line of remediation that took place was monthly high vacuum extraction, where a vacuum truck would come to the site. For 30 events over a period of 3 years, limited product was recovered through this methodology. There wasn't anything there to really enhance that product recovery. It relied all upon the vacuum from recovery wells and whatever fluid could be accessed and drawn through those wells. So needless to say, monthly high vacuum extraction was not the solution to this site. It was just the very first step. You know, as technologies become trends over various periods of time, the next thing that was attempted was small volume injection of sulfate across the site. It's well known that sulfate reduction takes place at virtually every petroleum site, and by feeding more sulfate to the microbial populations, one can often enhance the biodegradation of fairly significant hydrocarbon plumes. Well, in this case, again, the dosing was insufficient due largely to the permeability of the site, that we just weren't able to develop, or there wasn't able to be a sulfate reducing environment developed that was robust enough to make any kind of significant progress at reducing the hydrocarbon plume, and it surely was not going to be able to do much to address the LNAPL that still remained. Even if it wasn't showing up in the wells, it still remained out there in the form of ganglia. So the next technology that stepped up to the plate was air sparging and SVE. And this was installed after vapors were detected in some of the buildings on site and just off the site. And this occurred in 1996. So we started in the late 1980s, so we're already up to 1996. And then in 2008, a dual phase extraction system was put in place. So that was the next technology in succession. This is very common for gas station sites. I think one sees a litany of technologies that are applied, and you can have one technology after the next that's implemented. And I think what you're going to see by the end of this webinar is that combinations of things, or technology combos, are very critical to the ultimate progress on a site. And the history, part three. Antea Group entered this site in 2009. We inherited the dual phase extraction system, and it was a problem from the get-go. Had more downtime than runtime. In fact, we had one gentleman who was pretty much the main technician for this piece of equipment, and with bubble gum and duct tape trying to maintain it and keep it running, and say that facetiously, but it sure felt like that during the time that this system operated or tried to operate. The system was flowed through carbon and then ultimately to a sanitary sewer. We collected lots and lots of water with this system, over 250,000 gallons, but it was largely ineffective. We didn't get a whole lot of mass removed. So ultimately the decision was made to scrap this approach and move on to the next technology in succession to try to advance the site to its ultimate goal, closure / no further action. So we're done with our first segment of the webinar, and now we're moving on to the planning section. And this is head stuff, folks. This is thinking. This is the part of a project where you critically evaluate what you have and what you need to have as far as information / data. So with that, the first thing we did was go out and we collected a series of field parameters and updated geochemistry so that we could truly understand the overall environment that was present on the site. That's pH, that's temperature, that's DO, that's ORP, that's conductivity. So somebody will ask the question, well, do all those things always prove value? And the answer is no, they don't. But in combination, they do. So while one parameter may not present a whole lot of meaning, collectively they may tell you a significant story for the site. Then we also collected iron and manganese data, since at this point in time we were starting to consider ISCO as our technology approach for the site. And then with that, on the heels of it, we collected a soil sample for oxidant demand testing. I think that's something that can't ever be overlooked. Oxidant demand testing is a critical piece of information whenever anyone is considering in situ chemical oxidation for a site. It's that piece of information that will effectively tell you how much of my oxidant is going to be utilized by just the natural organic matter and by the metals present in the soil components. So this was a true soil oxidant demand test where it was actually the native soil in an unimpacted area of the site, and that's what was used for the testing as we began to plan for this site and the remedy that we were going to implement. Also, a high-resolution site characterization found its way into this project as well. Many of you are users of MIP technology or HPT, membrane interface probe, hydraulic profile tooling, water injection testing. These are fabulous tools that we have available to us, and these are things that give us more critical information that help us shape conceptual site models and also give us that critical information so that we can design remedies more effectively. For our site in Cedar Rapids, we used cone penetrometer testing. We were able to get in and identify those very discrete zones within the subsurface. I know this is a bit difficult to see, but you can see by some of the responses that we get and then some of the color coding on the left that there was considerable variability in the subsurface. And this variability was important because we could very easily go out to this site and say we're going to inject across a very, very broad length within the subsurface, a vertical horizon, maybe across the entire screen length of the monitoring wells. But I think these data tell us something much different. They tell us that there are very discrete zones where the mass is moving, where the mass is present, where the mass is sorbed. And these are zones that we want to target with our remediation and be more effective and efficient in how we use our remediation chemicals. We also use laser-induced fluorescence, or LIF, or LIF as many people say. And this too can make a difference in a site. It gives us the information we need, again, to identify those pockets of mass that are present, the things we want to target, and to what extent is that mass present? Here we have a very strong signal response. You look, we're almost 17 feet below ground surface, and we get a very strong response from the technology that says, that's a zone, that's an interval that we absolutely need to target with our remedial approach. So moving on, the other thing we did was we created a project team sign-off. This is something that I would encourage all of you to do that are on the call. If you don't have something like this already within your respective firm, you may think about creating it. And this is basically a form that sets up a series of questions that walk you through 3 distinct components of your project. The select phase, when you're actually pondering a technology or multiple technologies and trying to ask yourself, what are the characteristics that are going to help me pick a specific technology? And this may be something like, has this technology ever been used in my state before? Does my client have any reservations about this technology? So that's the select component of the project. You then move on to, once you've made a selection on a technology and you move on to the design phase, you then may ask yourself, okay, now that I've designed a particular remedy for the site, have I thought through all the ramifications of it? Have I thought what would happen if my chemical, my remediation chemical were to contact some infrastructure on the site? Have I thought through the permitting associated with an individual remedy for the site? Have I thought through all the different design characteristics? Have I collected the proper information at the bench or out in the field that allows me to verify my design? And then lastly, when you've gone through all that and you're ready to implement, have you really thought through the actual execution? You know, is your contractor's insurance up to speed? Are all the permits in place? Do you have a site-specific health and safety plan developed? You know, not just some generic one that you pull off your intranet site, but something that's specific to what you're going to be doing on the site and the chemicals that are present there. And then a real interesting one that is often overlooked, as I've done injection projects around the country, and Cedar Rapids here was certainly not any exception. Did you check with your local fire department to see what issues or considerations they might have related to an oxidant being brought onto site? Storing it, injecting it, that's often overlooked and can actually be a critical consideration. There may be some requirements from that local fire department, and in very rare instances, there may actually be a permit or a fee. So don't be surprised by that. And this type of a form that allows you to think through these questions and develop your responses is very, very important. So I'd encourage you to set up something like this to avoid unnecessary surprises. You'll notice here too there are a series of boxes that allow you to have each of the people on your project team, including your final reviewer, sign off that in fact they agree to the responses for each of these individual light items. So it's a very effective tool, and again, something I'd encourage you to do for each and every one of your projects, whether they're complex or not so complex. And then we get into this whole aspect of a partnership. You know, and this can be very controversial for those of us who are consultants out there. It seems awkward for us to say that we're forming a partnership with our vendor or with our technology provider. But I'll tell you, acting as if you're one as a project team is very critical to the success of the project. I'm not one to take a series of data or information, package it up in an email, and just fire it off to my vendor and say, here, send me a proposal back, thank you very much, I'll see you again in 2 years. Now, I'm much more interested in the details of going through that individual site with my partner on the project and going through the data and understanding the site collectively and then sharing each other's experiences from not only this site, but from sites all over the country, because experience is what drives it all. I'm not adverse to setting up a WebEx and putting figures on the board and having REGENESIS and Intake Group go back and forth and dissect the individual components of a project. And I'm also not one to just say, okay, you've given me a design, okay, we're running out to implement that. I think there's always room for pushback and dialogue and discussion and just that back and forth that helps shape a project and helps you really be focused and efficient. And then also, in our particular case, we have a high level of confidence in REGENESIS remediation services. I'm not going to do any disrespect to any other injection contractors out there because there are a number of good ones, and we use those too. But we've used REGENESIS remediation services on a number of projects. RRS is their acronym. And we found that they have outstanding equipment. They work safely, which is absolutely critical. And they have that finesse and that know-how to not be in a hurry and to really focus on the injection and focus on the ability to get chemical in the ground as opposed to splatter it all over the surface of the site. So this mentality of acting as a partnership, I think, is critical. And if you're not acting in that mode, I think you're shortchanging yourself on a project, and I'd highly encourage you to do it. Okay, we're on to our next segment here. And this is the implementation portion of the project. So we've set the history, we've set some of the basics, we've gathered some additional information. We've developed our design now, we've gone through our planning and our overall thinking, so we're ready to go. So some injection considerations for the site. First of all, everything we did had to be approved by the Iowa DNR. In our particular state, there's an injection by rule authorization that takes place through the EPA Region 7. So they're another component of this. We have to provide the specifics of a remediation design to EPA Region 7, figures, data, and allow them to evaluate the site as well prior to our going out and being approved to go ahead and put remediation chemicals in the ground. For our site, I mentioned we had free product. The goal was to get to less than 0.02 inches in any given well on site. And the ultimate goal was to have 2 semi-annual events below the site-specific treatment levels. Benzene being the most critical. We had to reach 1,100 micrograms per liter of benzene. And you'll see in some of the coming data that I'll show that we were upwards of 20 milligrams per liter of benzene in many of the wells on site. Toluene and ethylbenzene were also primary constituents at the site. Another critical part of the injection here was focusing on injection intervals that differ dramatically across the site. One size does not fit all, and neither does an injection event, so it's way too generalized to say, well, I'm going to go out and I'm going to inject this entire site across a 10-foot interval when that may not be necessary in certain portions of the site. And we use the CPT, the LAF data to help us fine-tune that and shrink those vertical intervals so that we can have quality remediation, focused use of the remediation chemicals. And this site had 11 monitoring wells and 4 target wells that I pointed out in some of the early slides, EFR 1, 2, 3, and MW15. And groundwater flow, again, was to the south, southeast. The chemistries, because they're important, and the opening chemistry for this site, and there are 2 of them that were utilized at Cedar Rapids. And the first one is CLEANZE, which represents enhanced desorption. It's that chemical that was utilized to really scrub the soil. You're looking at a picture there of the CLEANZE catalyst, the other active component of that being the infamous REGENOX Part A, sodium percarbonate. And we like the characteristics of CLEANZE. We like the fact that it does give you some direct oxidation. We love the fact that the catalyst has some sorptive properties. We love the fact that an alkaline environment is created which adds a detergency to the site, which scours soil. We also like the partial oxidation component that allows the hydrocarbon itself to be turned into a bit of a surfactant, a soap, if you will, which enhances recovery and helps deal with that LNAPL that's there in very, very fine ganglia, very fine layers. The other chemistry that was important here to the site was PersulfoX, which is an all-in-one self-activating persulfate ISCO chemical. Why, may you ask, do we go with this particular activation as opposed to anything else? There certainly are many activation mechanisms that are out there which we use as well, and they're very successful on other sites. But for our sites, which are very often gas station sites, the footprint we need to work in is very small. The need to mix separate activators takes up space. The need to have additional chemicals brought to the site takes up space. So when you can have a chemistry that's all in one to shrink the footprint of the area that you're working in, that to us is an extreme benefit on a site like such as this one. So let's get into our injection highlights. And we start off with CLEANZE, and our work took place in June, July, and August in 2014. Any of you who have ever been to Iowa know that we have really nasty winters, but we have really hot, humid summers. And we had some very challenging conditions to work in there, some 100-degree days and high humidity, and can be as challenging as anywhere in the country. So we did 3 rounds of injection with CLEANZE, 91 points in total spread over those 3 events. And the sequence of events was inject the chemical, wait 2 weeks for a full period of the chemical to run its life cycle, and then come out and run a high vacuum extraction event on the tail end of that, using a half a dozen recovery wells or so. And this became the sequence. And so we did multiple rounds of injection, multiple rounds of extraction, and that was the means by which we were scrubbing the soil and looking to remove as much of recoverable product as we possibly could to then take the burden off our Persulfox, which would come later. The generalized interval for this treatment was 16 to 23 feet below ground surface. It was 16 to 20 at some locations, 16 to 21 in others, and we moved this interval around. And so, but that was the generalized range. So we're looking at about a 7-foot vertical interval here, which does actually reach up into our smear zone as well. For PetroCleanse, we like to use a bottom-up technique. You can go top-down or you can go bottom-up. And with PetroCleanse, because of the frothy nature and the reaction component of the chemical, we chose to go bottom-up because it helps us keep more of the chemical in the ground. The injection volume for each event was on the order of 3,800 to 4,800 gallons of PetroCleanse, and that was the mixed catalyst with the oxidant component all in one. Interesting enough, down below, if you look at the photo there, you see this interesting little stain that emerged on the ground. Folks, daylighting, or surfacing as some people call it, is a fact of life. And you can have that on any site. And that doesn't mean you're being reckless. It just means that chemical can find its way through a transmissive zone and through the path of least resistance, and it can find its way to the surface. And when there are receptors there, one has to be diligent. So we had one person on our project team who was specifically looking for daylighting, up to 50 feet away from where the injection was actually taking place, and looking for those areas that could quickly be cleaned up and perhaps that chemical recovered and re-injected. So daylighting is a fact of life. It happened here, and it happens on almost every injection project. Well, following the actual injection of the PetroCleanze chemistry, then we went out, as I said, with the vac truck, which you're seeing a photo of there. We had 6 4-inch recovery wells. We targeted 1,000 to 1,550 gallons of removal per target well. Does it always happen that way? Absolutely not. As you can see, our recoveries were actually 870 to 1,300 gallons per well recovered during the 5 extraction events that we did. So we didn't hit our targets per se necessarily through each of the extraction events, but we still had some pretty good recovery. We had decent recharge on the wells, and we were able during those events to recover upwards of 130 gallons of actual free product, which made a significant difference in this site. And you run out at a point where we're no longer seeing measurable product on the site. So we went from feet to inches to tenths of inches to now the most we ever see at the site is a sheen. So we've done a pretty good job of hitting those ganglia, those LNAPL ganglia, and scrubbing the soils. We move on to our Persulfox. And the first event we did was in June of 2015, in a very comparable area to where we did PetroCleanze. We had 59 injection points, so a much bigger singular event than any one of the individual PetroCleanze events. And again, we stayed with a very similar target interval through the course of the injection event, again, varying it from area to area depending upon what our CPT and our lift data told us. We used a top-down technique in this case since we've shifted to a different chemistry. Persulfox in and of itself has a little bit of density to it, and like a lot of persulfate-based chemicals, you will see a density-driven effect where you'll have a little bit of sinking through the treatment zone, so hence a top-down technique to kind of flush through the area. In this case, we injected over 20,000 gallons of Persulfox at about a 10% solution. A quick answer to anyone who's wondering, can you go higher? Yes, you can. I've used 12, 13, 15% on different sites, but 10% was what was used here. We adjusted our spacing from 10-foot centers in the PetroCleanze injection to 8-foot centers in this Persulfox injection. We added ORCA, oxygen release compound advanced, along with the Persulfox in the same hole to help us get a little bit of extra bio kick on the tail end of the persulfate injection. You'll see that we later changed this and went to a different practice, but the whole intention here was to, once the ISCO chemistry was done doing its thing, that we'd have a little leftover biological treatment that would be present. We move on to our second and last injection, which took place in August 2016. So we're looking at a fairly significant gap in between, as we were looking at a fairly varied period of time for our monitoring events. In this case, based on the data we got from the first event, we shrunk our area down to 39 primary injection points. We also, through some soil sampling, discovered a little one-off area, which we called the secondary area. So we put in 6 injection points in that area. And you'll see by the intervals in the second bullet item below that, that in this case, we again adjusted the interval to 15 to 22 feet, generally across the target area, and 15 to 25 in the secondary area, the little one-off area we discovered. So we have a much, much broader interval there that we targeted for treatment. We again used the bottom-up technique. We had a lot more success with that with the CLEANZE, so we shifted to that for the Persulfox as well. And again, our injection volumes were a little over 5,400 gallons for the primary area, a little over 2,200 gallons for the secondary area. And again, 8-foot spacing, 8-foot centers was our target here, so we didn't go crazy. Going to much greater radius of influence, targeting that, I think doesn't respect the geology. I think you have to keep things tight, you have to keep it focused, and do everything you can to maximize your contact. In this case, we actually added the ORCA separately, which became a lot more efficient. It actually seemed to preserve a little bit more of the ORCA, and gave us a little bit more hanging around on the tail end to help us polish with bio. And I will mention that we used only Persulfox in the secondary area. We did not use ORCA in that area. A very critical component of any injection is the report you get from your injection contractor. That the pressures that were used to inject, the gallons per minute. If you can see any of the numbers on here, and you carefully, I'm pointing to the flow rate column on this injection report. You'll notice there are no numbers there in double digits. They're all single digit. 2 gallons per minute, 3 gallons per minute, 4 gallons per minute. Nobody's in a hurry at this site. The whole idea is to give lots and lots of residence time for the ISCO chemical in the site. So these injection reports after each injection event are incredible tools and very valuable to sit and scrutinize and understand from a single injection point or a series of injection points how the injection went in that particular area of the treatment site. And by all means, the notes from the field crew are very critical pieces of information. That's oftentimes something that clues you in when you do have problems, and we did with daylighting in certain areas. What were some of the adjustments that we could make? How could we rectify those situations? So the injection report is critical. So we're on to our last segment of the webinar here, and we'll have, it looks like, a generous amount of time for questions and answers, but we go to performance. And this was one of our target wells. And you'll see here the blue dots, the blue lines are water elevation. We get wild fluctuations in Cedar Rapids, Iowa. Cedar Rapids, Iowa is a city that floods quite often, so we do get tremendous variability in our groundwater elevations. The red is benzene concentration. It may be difficult to see. In this case, there are some gray boxes, and those are free product measurements that were taken at various time points during the course of individual years. I think the most important thing here is that EFR is in one of our most highly impacted areas. And one of the critical things that we want to show here is that following the PetroCleanze injection, where we're upwards of 30,000 micrograms per liter of benzene, we see a really nice fall off due to the original pre-treatment with PetroCleanze. We get a little bit of rebound over time, and then we have our Persulfox that kicks into play, and we get some very, very nice reductions to the point that, we've dropped significantly. And this is one of the worst wells here, and we've had over a 50% reduction at this particular well, and more recent data have shown this to be declining even further. So we're getting some benefit from not only the Persulfox, but also the ORCA. This is EFR2, which is another one of those focal points, kind of right in the center of the treatment area. And again, you see the same sort of characteristics, wild swings in water elevation, some fairly stout concentrations of benzene. Here the product measurements are colored in gold. And you can see that after the Persulfox, or the PetroCleanze injection, you notice you don't see much gold anymore. Even up to more recent times, we see only one instance where we've had any kind of sheen or measurable product that's been seen, and you'll notice that we've tracked downwards with a very, very nice trend on our benzene, which is our real focus of this cleanup. EFR3, again, this was the one that was sort of off to the side, almost right on the edge of the treatment area in the right-of-way. Again, wild swings in water elevation. Here we saw sort of a latent emergence of benzene finding its way into the groundwater, and again, after the use of the PetroCleanze to really scrub things out and tackle some of that LNAPL, we saw significant declines. We get a little bit of rebound. I think some of the more recent data I've seen, again, show this to be tailing off. So we're really in a polishing mode now with our groundwater treatment and reduction of our benzene concentrations. Just a few more slides. There's MW15, which is also a significant well that had a lot of product. We were only able to measure benzene there in some rare instances up until we started to use the PetroCleanze, until we got into the Persulfox usage. And now we're actually being able to measure benzene in this specific well. It was highly impacted. Lots of product, you know, had very high benzene concentrations. At one point we were able to measure it. And now we've had substantial reductions to where we're, 70% reduction from where we originally started. So we're getting some good response, and this site has responded well to the chemistries that were put in place. Again, maybe this shows it in a little bit of a different manner. We've had different risk levels that we're able to calculate in Iowa. Part of our Tier 2 program, you're able to model different exposure scenarios. And if you look at some of these target lines, and we look at the benzene for some of these different wells, we can see that we've gone below the standard in many, many cases. PetroCleanze helped us get there for sure, and now the Persulfox is really helping us maintain that, and we're well on our way to working our way to closure. Toluene, very similar. We do get a little bit of rebound here and there, but again, we're below many of the standards that were put in place on site, and we just continue to see those trends. They may bump up for a little bit, but then plateau off and then drop over time. So we still have a little bit of toluene that's present. Etyhlbenzene, much the same way. We get a little bit of scatter in the beginning, some very, very high concentrations, and we get a lot of removal. We do get some increases in concentration here and there as well after the PetroCleanze was put in place. And then we also get some such with Persulfox. And a lot of times that's a result of continued dissolution of the NAPL or desorption of more mass that's present on the soil. So you'll see a lot of these wells have trended down well below the regulatory standards that are in place. ORP, I think, is a very useful parameter to track when you're evaluating an ISCO site. As much as anything else on it, ORP can tell you a whole lot about how you're distributing your ISCO chemistry across a given area. Here you see with PetroCleanze, right as we add it, we get some nice response. We maintain that for a while, and then we see a blip again and an added increase once we hit Persulfox. We get that into the ground. Kind of goes along for a period of months, and then finds its way again as we get further on and closer to the next injection. We find an increase in ORP as our chemistry goes back in the ground. So ORP is a very useful parameter during the course of the injection, certainly at baseline, during the course of the injection, after the material is in the ground, and then for a period of weeks and then months after the injection event. Sulfate is also something we measure. Obviously, we wouldn't have that issue after PetroCleanze. Once the Persulfox goes in, we get spikes of persulfate, and we get some utilization of that sulfate in the subsurface. And one might ask, well, you're measuring sulfate. Could you have measured persulfate? And the answer is yes, we could have, and that's very commonly done. And we do that On some sites, there's some very nice kits that are available that allow you to do that, so it's an either or. Persulfate if you can. Sulfate is fine too. You can do that with kits in the field, or you can do that in the laboratory. So that's the other significant parameter that we monitor in addition to our target contaminants as well as our ORP, all the other field parameters in geochemistry, but we highlight sulfate as something else to monitor. So trying to wrap it up here before we get into questions and answers, the lesson learned here is that you can get substantial free product recovery with PetroCleanse. You can get a lot of desorption, and that's what we want. We've got to get it off the soil and get it into the water if we're going to do more in it. And I almost look at PetroCleanse as a pre-treatment. You know, it's not really what we're using to get to a particular standard. It's what we're using to tackle some of that robust mass so that we can get something more manageable that we could target with our next chemistry. The PetroCleanse mechanism does require some keen awareness. I pointed out the daylighting. Now, due to its frothy nature in general, that is something that has to be reckoned with on any given site. Daylighting is a fact of life. Managing it can be very straightforward, but awareness is the key. Persulfox and ORCA is a winning combo. You know, once the PetroCleanse has done its upfront job, the persulfate, self-activated combined with a bioamendment on the tail end is a winner. We've closed sites with it. We're in the process of marching this particular site in Cedar Rapids to closure, and so it's a winning combination. As long as you pay attention to the details, manage the information. Plan, plan, plan. I mean, that's a lesson learned from all of this, is that you probably cannot do enough planning for an injection event. You want efficiency, you want speed, you want results, and all that comes in the form of planning. And then lastly, we said it time and time again throughout this webinar, a good understanding of injection intervals translates to performance. So that means good sampling up front, whether that's cores, whether that's high resolution characterization, whatever that may be for your site, for your budget, whatever it is going to be to the good if you utilize those particular technologies. So path forward, we are actually negotiating an environmental covenant right now. That may in fact allow us to close the site sooner rather than later. I did point out that on the tail end that some of those more impacted wells, that we did see a little bit of rebound, nothing compared to what we initially saw, but there may be, depending upon the ultimate regulatory scenario, be some additional polishing. But we would see it as a very focused footprint and something that can likely be accomplished with one more injection event. Is it possible to close a site with a singular injection event? It's possible, but I would always say that you're always looking at managing a series of injection events. If you're ultimately going to get to a no further action to a closure scenario, you have to go in thinking that this is going to take me multiple injection events, and that based on what I learned in the very first one, my second, third, maybe even fourth injection event are all going to be managed based on the data that I see. And I mentioned the 1-800-Flowers, Flowerama. Don't ever schedule an injection event in February or early May because they get really mad at you if you're going to tear up their parking lot right before Valentine's Day or Mother's Day when they do 70% of their business. So just another one of those little awareness tips that I'll leave you with. So I greatly appreciate your time today. I hope there's been some useful things here within this webinar, you know, whether they're technical pieces, whether there's just some lessons learned, and now we'll have a generous amount of time here to answer some of your questions. And with that, we'll turn it over to Dane for question and answer. I posted my email address here if you want to email me questions or comments. And I will like to acknowledge here our project team, Kirby Smale, who has run this site for years and done so efficiently. And then our field team, Molly Partridge, Randy Lightfoot, and Nick Fulton. Nick's the guy that babysat that dog of a DPE system for so long a period of time. So hats off to the project team for a job well done. Dane?
All right, thank you, Jack. That concludes the formal section of our presentation, and at this point we'd like to shift into the question and answer portion of the webcast. Before we do this, just a few reminders. First, you will receive a follow-up email with a brief survey. We really appreciate your feedback, so please take a minute to let us know how we did. Also, after the webinar, you will receive a link to the recording as soon as it is available. All right, so let's circle back to the questions. We do have a lot of questions today, so if we run out of time before we get to your question, we'll make an effort to follow up with you after the webinar. Okay, so first questions, we got a few questions related to injection pressure. Was this high or low pressure injections? And also somewhat related, could you remind me what was the hydraulic conductivity of the glacial till?
Yeah. In this case, the hydraulic conductivity varied some across the site between 10 to the -4 and even 10 to the -5 in some locations. The injection pressures were higher in those tighter areas. We did get upwards of 50 psi in those locations. We have an internal standard to stay below 100 psi sustained, but we got nowhere near that in this case. But 50 psi in some of the tighter areas, and generally in the other areas about 20 to 25 psi. On a lot of these sites, managing flows and pressures, we like to stay even down as low as 10 to 15 psi, but in this particular case with the glacial tills, there was some additional pressures.
Okay, all right, thank you. So next question here, what technique do you use to target a specific horizon in the well?
Yeah, I mean, we use direct push on a lot of these applications. So we'll either push down a specific interval or rise up a specific interval to load chemical into a specific 1, 2, or 3 foot horizon. So we do it surgically, we do it slowly, again as low a flow as we can possibly get, at as low a sustained pressure as we possibly can. So we get that contact time and we get that sustained scenario.
Okay. All right, so next question here. Looks like there is an inverse relationship with water levels versus benzene concentrations. How confident are you that you won't have additional rebound when the water levels change again?
Yeah, that's a really good point and very, very common. I mean, we're not talking about anything new here. That's a pretty common phenomena we see at most every site. But I think our confidence lies in the fact that we're getting a generous amount of injection chemical in contact with our mass. We know where it is. We're not getting crazy in terms of our vertical injection intervals. We're keeping it very concise and very sustained. And our rebound now is not as substantial as we saw it in the past. Again, we have risk-based standards here, so we don't have to get to 5 micrograms per liter. I'd be very, for benzene, I'd be very concerned if that were the case. But because we have these risk-based scenarios and they're much, much more generous, I think I'm pretty confident that we're going to get to those or very, very close and be able to close the site out.
Okay, great, thank you. So a couple of questions related to the different technologies used. Jack, you described a combined remedies approach that required multiple mobilizations, injections, and the like. Wouldn't it be more efficient just to pick one technology and implement it hard? Why does the combined remedies approach, why is the combined remedies approach in the best interest of your client? And then another related question says, this all sounds expensive. Can you touch on ballpark costs?
Yeah, I'll touch on the costs next. You know, this whole combined remedies thing, are there sites that can get away with a singular technology? Absolutely. You know, countless numbers of them. I just find that with combined remedies, you can take advantage of the best of each and every component of those remedies. And I think if you extrapolate out the costs, when you have a combined remedy like that, you wind up saving more money in the long term than you would if you went a singular remedy in and of itself. I think that's been proven, especially in more recent presentations that I've observed. When you combine those remedies, you're putting each particular approach in the best light, in the best scenario that you can possibly have to make that chemistry, that approach be as efficient as possible. You know, as far as cost goes, you know, the products cost what they cost. So really it comes down to efficiencies in the field. You know, the mob cost, your actual injection time. I will pay more for an injection contractor who takes his time and talks and shares information and makes observation any day. So I would say that our injection events varied anywhere from about $40,000 per event to some of the larger ones, which were upwards of $75,000 per event. So expensive, you know, that's a relative term. I look in terms of quality of effort and efficiency, and it's not too expensive if progress is made.
Okay, great. Thank you, Jack. So next question, we have a couple questions relating to volumes. First one is, please convert the volumes of chemical in gallons injected into the ground into pore volumes. Was it 1 or 2 pore volumes of chemicals injected? Related question, for each product injected, seems like over 100 gallons per point. Is that right?
Yeah, there were definitely over 100 gallons per point, somewhere upwards of 200 gallons per point, depending upon the chemistry. You know, we try to approach a pore volume. There are certain sites where we really load the fluid and push upwards of multiple pore volumes. But a lot of these ISCO efforts, particularly with PetroCleanze, we try to load that aggressively. So 1 pore volume, a pore and a half, pore volume and a half. A lot of times with an ISCO approach, we will load less than a pore volume. It just depends from site to site. But again, it's the most fluid we can get in as efficiently as possible, given the respective geology and hydrogeology on a site, to get the most contact. And that's subject to change from event to event.
Okay, great. A lot of questions also about the contaminants. One of them is, what is your benzene cleanup level? Related to that, does Iowa require analysis for triethylbenzenes, and if so, what were the results for this constituent? Another question says, what were the results for MTBE, if it was a constituent of concern at all?
So first and foremost, MTBE was not a constituent of concern at this site, although I got a variety of MTBE sites going on right now, and this particular chemistry in association with it, particularly the Persulfox. You know, as far as Iowa, they have these risk-based standards. Our goal right now is 1,100 micrograms per liter for benzene based on our current risk scenario. There are higher standards, there are lower standards depending upon the risk scenario, the exposure scenario, you know, proximity to utility corridors, you know, those sort of things impact the overall target level for a given site. Dane, can you repeat the question one more time? I think I'm missing an element of it.
There was one about Iowa specifically. Does Iowa require analysis for triethylbenzenes, and if so, what were the results of this?
Yeah, that was the one I missed. No, not specifically on this site, although we do get specific requests from our regulators from site to site, but that was, again, not an issue on this site.
Okay, great. So another question here. You mentioned that you preferred bottom-up injection based on experience at this site. Is this the general case for most of your sites?
I would say that we do more bottom-up injection than top-down, although I have no specific preference. I just found that with the way these chemistries work in a lot of scenarios, that the bottom-up injection works better for us in terms of daylighting, but there are other sites where we've had just splendid results with top-down. So I think a lot of that comes into play when you're planning the site and you're in conversation with your injection contractor and your direct push company, getting their experience and the benefit of their knowledge as well, I think that's critically important.
Okay, all right. Looks like we probably have time for maybe one more question, 1 or 2 questions.
Okay.
During high vacuum extraction events after injection, how was the volume of free product recovery measured?
Yeah, it wasn't measured on site. Our particular vendor gave us a particular estimate as they removed the product back to their facility for disposal. So they gave us a quantity as they separated out the total liquid that resided within their vac truck and brought it back to their facility. That's where we got the designation of how much product was removed.
Okay, great. Maybe time for one more possibly here. So Jack, you mentioned how you often use REGENOX as a front end to bio. Is this for the oxidation, the desorption, bioavailability, an oxygen kick, or some other reason?
Yeah, we've closed countless sites with the combinant, especially here in Southern California, with REGENOX Part A specifically and ORCA Advanced. The purpose of the REGENOX Part A is, hey, I'll gladly take whatever direct oxidation I can get, although I don't expect a tremendous amount based on how we load it, but I do expect a tremendous amount of desorption based on the alkalinity of the chemical, as well as just how efficient it is at scrubbing the soil particles. So we use it as a soil scrubber, and that has proven to play out time and time again as a much better mechanism for us than just going in directly with either REGENOX or ORCA.
All right, thanks very much, Jack. That will be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you have any questions for Jack Sheldon, you see his email there on the screen. If you need immediate assistance with a remediation solution from REGENESIS, please go ahead and visit regenesis.com to find your local technical representative, and they will be happy to speak with you. Thanks again to our presenter, Mr. Jack Sheldon, and thanks to everyone who could join us. Have a great day.